Good evening, everybody. Welcome back to another YouTube live or live sessions. So we will be discussing on the topic called oceanography analytics. So before starting the oceanography analytics, so let me give a little bit information about the domain analytics that we are conducting for you. So we are initially start doing projects on the domain analytics. So some of you are working on the domain analytics. So we have multiple domain analytics parts. So what kind of domain you want to choose as we go ahead, domain is very important to us. So before I begin, people who are new to this session, I will give a little bit brief information about the institute, which is called as 360DigiTMG. Give me a second. Yes. So here when we type 360DigiTMG, you will be open to this page. So here we have plenty of courses. We have data science, data analyst, on cloud computing. Here we have the domain analytics courses also. So we are conducting HR analytics, market analytics, financial analyst, and cybersecurity analyst. We have many more which are coming. We have on supply chain, life science, and this is regarding the institute. We also offer courses on the Python and data engineering also. We have many things. You can check our website. So let's move on to our topic, which is called as oceanography analytics. So I got a chance to express on the oceanography analytics. So we will discuss one by one about the oceanography analytics. So what will be covered in the oceanography analytics? Before that, I want to know what is an oceanography analytics. So let's start with what is oceanography. So in a simple words, oceanography is nothing but the study of all aspects of the oceans. Sorry for the interference. So the study of all aspects of the oceans is called oceanography analytics. So in the oceanography, we cover a wide range of topics from marine life and ecosystem to the current and waves. So the movement of segments and seafloors of a geology. So this is about the oceanography. We will discuss on the oceanography analytics. So we will be learning in deep with the oceanography analytics. So what will be come under that? 1 minute. Yeah, so we will be discussing on the applications. What are the applications we'll be using the oceanography analytics? Then we will discuss on the MLQ methodology. So what will be the MLQ? What will be needed? How will be the work? Then we'll discuss on the exploring data analysis and data preprocessing, which is nothing but ADA. We generally call an ADA and data preprocessing. After that, we will discuss on the data mining and supervised learning, which is nothing but K-means clustering. Then KNN, then later on decision tree. Then we have linear regression. Last but not the least, on the multi-layer perceptron MLP. So we will be discussing on these topics one by one. So first we will move on to the oceanography again. My mistake, sorry. How machine learning is useful in oceanography. Question mark. So we'll learn how a machine learning language is useful in oceanography or oceanography analytics. So here we'll start with the machine learning topic. So the main application, we can say applications. Yeah, so the main applications of a machine learning in a oceanography is, let us type here, nothing but prediction of the weather and climate. So here, the main application of the machine learning in the oceanography is prediction of ocean water or the ocean weather and the climate. So habitated modeling and distributions, species and identification, coastal water monitoring. So the marine resources and the management and the detections of oil spill and pollution and wave modeling. So this will be useful in the machine learning language. So how a machine learning will be used here? So there are some 6 real examples of a machine learning ML is being used. We have image recognitions as well as widespread example of machine learning in the real world. Then we have speech recognition, medical diagnosis, statistical attributage, predictive analysis, extraction, web applications. We have many more. So, as we know, machine learning is a subset of AI. So, we'll discuss in brief so that you will be known. Yeah. So, machine learning is a subset of AI, which is artificial intelligence. So that's enabled to take decision based on data. So the artificial intelligence make possible to integrate the machine learning. So it will integrate to the machine learning. After that, so the machine learning capabilities into the data-driven modeling systems in order to bridge the gap and lessons demands on human experts in the oceanography researches. So we have, sorry, excuse. So here, machine learning algorithms have proved to be a powerful tool for analysis oceanography. And so the climate data with a high accuracy efficient way, machine learning has a wide spectrum of real-time applications. So in the oceanography and the earth science, so the study of explained in simple way. So the realistic use in the applications of measure of machine learning algorithms. So the main application of the machine learning in the oceanography is prediction of ocean, weather and climate, habitated, modeling and distribution, as I mentioned in before some time, and detecting the oil spill and pollution and wave model. So this was about the how machine learning is useful in the oceanography analytics. So as we move on to next, here we have, so done. So here we have some types. Here we have 5 types. So there are 5 types of oceanography. So we will discuss one by one all the 5 topics. Then we will conclude some use cases. We will look into the use cases also. So then we will get an idea about what is oceanography analytics. So before that, we will look into how AI is helpful in the oceanography. pretty much same as machine learning, but little bit a difference in that. For the artificial intelligence in the ocean science or oceanography. So, oceanography research is a multidisciplinary endeavor that involves the acquisitions of an increasing amount into the C2 and remotely sended data. So, a large and growing number of studies and the data repositories are now available online. However, manually or integratedly, different data sets is a tedious and glaring process, leading to a rise need for automated integration tool. So a key challenge in oceanography data integration is to map between the data source that have no common schemes and that were collected, proceed and analyze using what we called, I will type here, which is called as methodology. Is called as methodology. So concurrently, artificial agents are becoming increasingly adapted at extracting knowledge from the text and using domain onto it, as I told before starting the session about the domain. Then later on, we have development of AI based on the tools assisting ocean scientists and their schemes with existing ontoys where organizing their measurements in the data set. Okay. Then we have extension and refinement of conceptual coverage of alignment between existing ontologies to better fit the diverse and multidisciplinary nature of the ocean science. So creation of ocean science specific entities resolutions benchmarks to accelerate the development of tool using oceans. So this is regarding the ML and AI in the oceanography analytics. So we will be discussing on the 5 models that are 5 types of oceanography analytics. So the first we have is physical oceanography. So let me clear all this. We will be discussing on only one topic. Yeah, so the first topic will be physical oceanography. So what is physical oceanography in the oceanography analytics? So let me clear for that. Then we'll move on to the what will be in the physical oceanography. Basically, physical analytics, physical oceanography is nothing but the study of physical conditions and physical process within the ocean, such as waves, currents, winds, eddies, and tides. And so the transport and sand on and off beaches, coastal erosions, and made interactions of the atmosphere and the ocean. We can say further for the physical oceanography. So physical oceanography is one of the several subdomains in which oceanography is divided. Others including we have chemical oceanography, biological oceanography, geological oceanography, paleoceanography. So we will discuss first physical. So the descriptive physical oceanography seeks to research the oceans through observations and complex numerical models which describe the fluid motions as precisely as possible. So that dynamically physical oceanography focus primarily upon the process that governs the motion of fluid with emphasis upon theoretical research and numerical modes. These are parts of large field of geophysical fluid dynamic GFD that is shared together with metrology. GFD is subfield of fluid dynamics. So roughly 97% of the planet water is in the oceans. And the other sources of the vast majority of water vapor that condenses in the atmosphere and falls as a rain or snow on the continents. So that excuse me. So the tremendous heat capacity of the oceans moderate the planet's climate, and its absorption of various gases affects the compositions of the atmosphere. So the ocean's influence extends even to the composition of volcanic rock through seafloor metamorphism, as well as the volcano gases and magmas created by subduction zones. So here we have about the physical oceanography. So in the complex physical interplay between winds, between winds, and we have waves, water, density, we have pressure, then we have temperature, we have solar radiation, and solar radiation and the hard boundaries. Of the ocean. So wind, waves, water density, pressure, temperature, solar radiations, and the hard boundaries of the oceans, which make physical oceanography a challenging subject. So we have challenging subject. So this was about the physical oceanography. We will discuss on that. So in the physical oceanography, we have studied the relationship between ocean and physical properties, and we have discussed about the atmosphere, sea floor, and the coasts. So the investigation, ocean temperature and density, waves, tides, and currents that I have mentioned here. They also focus how the ocean interacts with Earth atmosphere and to produce our weather and climate systems. So this was about the physical oceanography. We will move on to the next module, that is nothing but chemical oceanography. Yeah. So what is chemical oceanography? So So what is chemical oceanography? So nothing but study of chemical components oceans. So the study of chemical components of the oceans, then their reactions and their pathway of the transformations. So we study both on organic and inorganic components. So particulate on the dissolved material and the ocean segment. So mainly the chemical oceanography plays a central role in the understanding the distributions and reactivity of the chemical component within the oceans and at the earth ocean, sediment oceans and atmosphere oceans. So they both interfaces here. Then the ocean covers approximately 70% of the Earth's surface, as we know, and the average depth is up to 3,900 meters. So I'll mention here is nothing but 3,900 depth. So I don't know how many of you know, we have one person is called as the father of the chemical oceanography. His name is Robert Boyle. So his name was Robert Boyle. So during the 1600s and 1700s, Robert Boyle and his observation and experiments about the saltness of the sea in 1674, if I'm not wrong, which was the option of the several random modern writers, established him as a founder of science that is now referred as a chemical oceanography. Another we have who was the father of the ocean, we name as Captain Cook. So he was the first ocean scientist. Although his trips were 100% science, he was an excellent navigator, ambassador, and explorer. His three voyages between 1768 to 1780 produced maps, charts, and numerous scientific samples in the ocean field. So this was about the Captain Cook. So this was about little bit of a chemical oceanography. In detail, I will explain. So the origin of the, one second. Yeah, the origin of the study of the chemicals and origin of the chemicals of the ocean. Frequently termed chemical oceanography or marine chemistry. So can be formally traced to the 3.5 year expeditions of the HMS Challenger in 1872. So that research cruises collected samples and species to the study of biology and chemistry and geological of the water. So a major chemical finding was the constancy in the ratio of the major ions, which are sodium, calcium, magnesium, chloride, and sulfate. So to each other throughout the oceanic water column. Since that time, analytics chemistry has played a fundamental role in the chemical oceanography. As mentioned, development to determine trace elements at micromolar and nanomolar. Since that time, analytical chemistry has played a fundamental role in the chemical oceanography. So this was about the oceanography. So before starting the biological oceanography, I want to explain about oceanography topic a little bit more so that you will be aware introduction part. So yeah. Yeah. So the oceanography is a study of physical, chemical, and biological features of the oceans. So here we have four 1, 2, 3. Yeah, 4 features: physical, chemical, biological of the oceans, including oceans' ancient history, so its current condition and its futures. So in the time when the oceans is threatened by the climate change and pollutions, coastal lines are eroding, and the entire species of marine life are at risk of the extinction. So the role of oceanography may be more important now that it has been in ever. So the oceanography covers more than the living organisms in the sea. So in the sea, we have many living creatures, reptiles, fishes, whales, etc. So a branch of oceanography focuses on the formation of the sea floor and how it changes over the time. So the main point here is, so the branch of oceanography focus on the formation. So it will be focused more on the formation of the sea floors and how it changes over the time. So it will look into the time changes in the weather conditions in the oceans. So then we have geological oceanographers are starting to use special GPS technology nowadays because the technology has on the peaks. So they are using GPS technology to map the sea floor and other underwater features. Here, sea floor is one upper layer of the sea, and underwater is in the underwater feature. So, in additional to the biology and geological oceanography, there are two other main branches of the sea science. So, one is the physical that we have discussed, the study of the relation between the sea floor and the coastal and the atmosphere. Another is the chemical that we had already discussed just now, the study of chemical compositions in the seawater and how it's affected by the weather, human activities, and the other factors. So this was about the oceanography intro part. We will discuss here that we are stopped for a while. That is nothing but biological oceanography. So we will be discussing on the biological oceanography. So what is biological oceanography? The basic question. So let us discuss about the biological oceanography. The study of organisms affected by the physical, chemical, and geology oceanographic systems. So the study of organisms affected and are affected by the physical, chemical, and geological of the oceanography systems. So biologically, oceanography may also be referred to as ocean ecology, in which the root word of ecology is okia, meaning house or habitated in the Greek. With that mind, it is of no experience no surprise that have the main focus of the biological oceanography. So the oceanography is one of the microorganisms within the ocean. So looking how they are affected by their environment and how they are affected by their environment, how that affects large marine creatures and their ecosystem. So biologically, oceanography So we have So we have discussed biological oceanography. So oceans occupy about 70 to 71 So here oceans have about 71% of the Earth's surface. So this says that the average depth of the oceans is about 38,000 meters and the depth part of almost 11,000 meters. So the marine environmental has the total volume approximately 1370 into 10 to the power 6 kilometers per power 3. So that is 300 times larger for life than the volume of the land fresh water combined. After that, we have it thought that the earliest organizations and they orientated in the ancient oceans long before any form of the life appeared on the land, and the ocean biology is dominated by the organisms that are dominated atmosphere. For the reason we cannot make assumptions about the ocean's life based on what we know from the land and the atmospheric model. The range of diversity of the life in the ocean is one of the main motivation behind the continuous study of biological oceanography. So such things to such a range in the diversity means there is need for a range of equipment and tools used to study the diversity. So with the ocean organisms being much more inaccessible and not easy observable related to terrestrial organisms, there is a slow growth of knowledge and a consistent need further exploration and study. So the second main motivation behind the continuous study of biological oceanography is climate change. Here we have so the biological oceanography ties closely with the physical and chemical oceanography. And the detail we learn from the biology and oceanography tells us information about the bigger picture and and help us to build models of large scale processes. Such models are even more critical when global environmental is changing at an unprecedented rate. So there are global patterns in environmental conditions, such as changes in pH, temperature, salinity, and CO2, but not everywhere sees the same change. So the ocean makes the earth habitated through regulations of the earth climate and process, such as primary productions, which provides oxygen as a byproduct, of course. So biology is the central of facilitating some of the process, but the climate change and the human impact of the ocean environmental is consistently changing, and so it is called as for consisting and continuous research. Sometimes the main question that a biological oceanographer seeks to answer many include so some of the main questions I was discussing that the biological oceanographer seeks to answer the many include what sort of the organisms inhabit different sectors, and depth of the oceans and why. So a lot of biological oceanographer research studies and the production of the organic matters by the ocean life and examines what factors affected their growth, and as a result the production rate of organic matters. So some biological oceanographers look like the relationship between organisms themselves, all the way from microbes to whales, and some look at the relationship between the certain organisms and some chemical and physical characteristics. So biologically, oceanographers also seek to answer questions with some more direct and immediate impact of the humans, such as asking what we can expect to harvest from the sea. So it's a nice question. And whether the seasons or the recent natural disaster may affect the fishes. So this was about the biological oceanography. So as we move on to the geological oceanography and paleoceanography, we will discuss on a use case. So we will get an idea on the oceanography and yeah. So we'll discuss on the use case. Give me a minute. Yeah. So we'll look into the use case. So the use case will be some of the chemical sensors, technology, current and future applications. So I will give a short note on this introduction and use case. So over the past decades, population growth has increased in the sense of the arguments to the better understanding human impact on the oceans and the atmosphere. It is crucial to improve measurements and critical variables. So if you are not able to distinguish natural from the anthroponic changes, so the new chemical measurements techniques are continuously being sought to improve the education, limits accuracy, and to obtain in situ and real-time data in the global ocean. An important aspect of understanding complex oceanic process is being able to detect the quantifying the true or in situ value of the chemical component. So rather than the alternated value that may be resultant following as period of degradation or change that may occur after a sample and removing from the natural environmental. So the traditional measurements methodology currently used as a chemical oceanography, such as chromatography, if I'm not wrong, and high performance liquid chromatography. So this was about the intro. Then we have a problem of identification in the oceanic chemical process that may be contribute to global climate change in different and challenging. So the documented increase of greenhouse gases in the atmosphere, especially chlorofluorocarbons, carbon dioxide, CO2, is also an ocean research area that has received much attention in the recent years. So the atmospheric CO2 has been measured continuously since 1950 to determine global concentrations. Sorry. So within this result showing increasing concentrations. So the effect of ocean pollutants is an near coastal water, and the transport into the offshore water has remained high on the public and political agenda. So since the early 1970s, cross 1976, great program has been made in the understanding the effects and underlying mechanism associated with the number of the toxic substance. So this was about the intro. In this, we have baton tripod, offshore platform, drives and floats, underway shipping, shipboard sampling. Then we have submersibles, ROCs, AUVs. So let us discuss about the future chemical sensors technology. So the current field analysis technicians are often based on the proven methodology, which are using the laboratory instrumentation, future large-scale oceanography program. So we'll demand a new reliable and improvement chemical sensors. So the technology for the ridiculous and repeated use in the oceans. So this section will discuss and suggest some of the innovative and emerging sensor technologies that may prove useful in the ocean measurements and monitoring program in the future. Then we have fiber optical chemical sensors. So the fiber optical chemical sensors offer a completely new approach from methods currently used by chemical oceanographers. So these sensors have been number of advantages over conventional wet chemical sensing techniques. So this can be made of rugged and simple to operate. Analytical monitoring can be accomplished remotely, and unlike potentiometric sensing, so a referral signal is not required. So the measurements using a fiber optics sensors system are done in situ and in real time. So this section will describe basic sensors and operations. So this was about the use case. So we will be discussing on what we are discussing. So we have done with, let me show. Yes, we have done with physical oceanography. We are done with chemical oceanography. And just now we have completed biological oceanography. We will discuss about the geological oceanography. So what is geological oceanography means? It is nothing but the study of segments and rocks within the marine environment. So basically, geological oceanography is the study of Earth beneath and the oceans, segmentation and the rock within the marine environment. So it involves geochemical, geophysical, sedimentological, and paleontological. So the investigations of the ocean's floors and coastal margins. So the geological oceanography includes exploring the ocean floors, and so the process that forms its canyons. And we have the examine of the various ocean features such as rise and ridge. Then we have geological oceanography is one of the broadest field in the earth science. Excuse me. And contains of many subdisciplines, including geophysics and plates techniques and petrology and segmentations process and micropaleontology and stratigraphy also. Then later we have other way, ocean segments are studied by the dredging process and deep sea explorations projects such as Ocean Drilling Program ODP. Within the obtainment of sample of seafloor segmentation from the entire world, so the ocean segments are found to the constants of rock particular and organic remains whose compositions depends on the depth. So the distance from the continental and local variations such as submarine volcanoes or high biological activities. For example, clay minerals, which are formed by weathering and the continental rock, are carried out by the sea, by the river, and they usually abundant in the deep sea. So the thick deposits of the weathered rock material, commonly coarser than deep sea clays, are often found near the mouth of the rivers and the continental shelves. So in the geological oceanography, we study the both contemporary and ancient environmental using field studies and computer models to understand how these systems have studies computer models to understand how these systems have responded to the change and predict how similar systems today will change in the future. So this was about the geological oceanography. So when we move on to the last topic is paleoceanography. So what is paleoceanography? So the study of oceans of the past from a few years to billions. So paleoceanography is the study of oceans of the past from few years to billion of years ago. So basically paleoceanography provide information of the on rate of the process of environmental change in the past, those on the linkage between the for example, atmospheric PCO2 levels and rate and the magnitude of the climate change. So the change in the ocean chemistry, including identification and deoxygenations and marine ecosystems responses. So who found the paleoceanography? So Cesare Emiliani, the founder of paleoceanography. So paleoceanography makes use of so-called proxy methods as a way of infer informations about the past state and evolutions of the world oceans. Several geochemical proxy tools, including long chain organic models, stable and radioactive isotopes, and the trace methods. Additionally, segment cross can also be useful in the field of paleoceanography. is closely related to the segmentology and paleontology. So let me keep this arrow so you can understand what we are discussing. So it will be helpful. So this so the most common used proxy to interface is deep sea temperature. So the temperature inferred from the MgCA ratios as confirmed upon to the 3 degrees cooling of the depth ocean during the late Eilstone Glacial period. One notable study is that by the Lear et al., who work to calibrate bottom water temperature to MgCA ratios. So the segmentation records can tell us the great deal about their past and help make interference toward the future. Through this area of paleoceanography is nothing new with some research going back to the 1930s and earlier. Modern time scale reconstructable research has advanced using segment core scanning method. So these methods have enabled research similar to that conducted with the ice core record in Antarctica. So these records can inform on the relation abundance of the organism present at the given using paleoproductivity methods, such as measuring this, the total abundance records can also be informed on historic weather patterns and ocean circulation, such as Deschamps et al. So this research into segmentation record from the Canadian Beaufort margins. So in this, we have to discuss a point which is important in the paleoceanography. So paleoceanography data are derived from many proxies found in the deep sea segmentations, as I mentioned in before. So which includes the trace metal and scotopic compositions of the fossils, platox species, compositions, and lichenology. So this was about the oceanography. So as we moving forward, we have done with all these things. We have done with physical, chemical, biological, geological, and oceanography. So we have done with these 5 modules of the oceanography analytics. So what are the advantages and the disadvantages? So we will discuss about the advantages of the oceanography analytics. So I have some 5 points. We will discuss on other points too. So the first point is the ocean is our life support system. Yes. Why? Because from the oceans we have seafood, sea resources, sea transport, ocean transports. We have income from the oceans. So it is our life support system, as I think. Then the ocean provides food, jobs, and livelihoods. Yes, it is. Then we have the ocean help fight the climate crisis. Then we move on. Then we have the ocean is a home to vast biodiversity, which provides well-being benefits to the all the humanity. So this was about the advantages. So the disadvantages are funding scarcity. Funding is an issue for many oceanographers, I think. So first one is the funding to the oceanographers. So there is not as much as funding to the oceanographies. Those are working on oceanographic top. Then in the second we have education requirement. So it takes a significant amount of educations to qualify as an oceanographer. Then it has required travel. We can say traveling. Then another we have schedule complications. So these were the disadvantages of the oceanography. So as we move on, these are the advantages and disadvantages of the oceanography analytics. Here's some of the challenges. So oceanography analytics are likely dependent on the data. So if there are weaknesses in your data, there are weaknesses within your resulting analytics. So if you want the correct data, current output, the correct information, so your data should be good. As I think need to be large data set. Yes, of course, we need a large data set for the better understanding of the model in the ML or AI or any what we use. Then we have inaccuracies in data, biased data, lack of spontaneous tagging, over reliance, non-considering of data. Then we have black box algorithm also. So here I have used some use cases, which are Marine National Facility, Ocean Data Protection Integration, PDNs, HPS, and the chemical sensors. I've used many other. So these were the 4 that I thought might be helpful for my domain analytics, which was I was working on the oceanography analytics. So these were the 4 use cases that I have used. Then we will I will give a note on the oceanography. I can say some few points, main points. So the rapid development here, the rapid development of ocean observations technology has resulted in the accumulation of a large amount of data, and this is pushing oceans science towards being data driven based on the type of distributions of oceanography data. Based on the type of distributions of oceanographic data, these paper analysis the present and makes predictions for the future, degrading the use of the big and small data in the ocean science. The ocean science has not full entered in the era of the big data. So there are two ways to expand the amount of oceanography data. So to understand and to management of the oceans on the data level, full exploratory the potential value of big and small ocean data and the transformations and the limits some small into rich big data will help to achieve this on the application level of oceanography data or the get great value. So if we realize the radiation of the core of the data and the consumers, the oceanography data will provide not only a reliable scientific base of the for the climate, ecologically disasters and the other scientific research, but also which provide an preferential rich source of information that can be used to the make of the prediction of the future in the oceanography analytics. So BIOS is an offshore platform used to carry all kind of ocean and atmosphere sensors. BIOS continues an important part of the ocean monitoring systems and constraints and the other monitoring methods. So BIOS can also perform automatic, continuous and long-term synthesis and monitoring of the ocean environmental under the extreme environmental conditions. So which provides a temporal and special extensions of the monitoring. The first appear was during World War II. So the system was used to United States in early 1950s for surface and deep sea environmental monitoring plans. So this was about the oceanography analytics. So before I stop the things, I would like you to do one thing. Go and search to the 360DigiTMG. You can find different courses for the domain. If you are interested only in domain, we have plenty of courses: HR analytics, marketing analytics, finance, cyber, data science for internal auditing training, aviation, customer, supply chain, all that. And we also have plenty of things you can learn from us, this institute. We have businesses We have blogs, mind map, learning resources, all those things. You can have a look in that. So this was about the oceanography analytics. So we have learned physical oceanography, we have learned chemical oceanography, then we have discussed about biological oceanography, geological oceanography, and last 5 oceanography. So these are the 5 types of the oceanography. Thank you so much for the patience. One minute.